Hi, Amy. How are you doing?
Hi, sir. I'm good, thank you. How are you?
Very good, very good.
Good.
So last time we did talk about transformations and inverse functions. I hope you understood all the concepts.
Yes, I did very clearly.
Uh, Should we have some questions on that just to review, and then we'll move on to the next unit and look into what is absolute function or modulus function. Okay,
Yes, yes, please. A
so
good recap would be great.
let's do that. Right. So it'll be a very short recap on transformation. Right. So let me share with you the screen. Right here, right? So this is, you can see the screen, right, on transformation of functions.
Yes, I can.
Perfect. So just a recap, what, can you tell me what this inside terms when we have a transfer function g of x equals to a times f of k times x minus p plus q, right? So
Yeah.
the terms, when we look at the transformation, what does k and p signify?
So anything inside of those square brackets signify the horizontal, whether it's compression, stretch, or translation.
Correct.
But then with the P, we learned that that's to do with only horizontal translation, so either moving left or right.
Correct.
Depending on whether P is greater than 0 or less than 0. And then
Correct.
K is to do with the horizontal compression or stretch by that factor 1 over K. So when
Yes.
you, yeah, solve.
Perfect. And can you explain how the original point gets transformed into this image point based on the transformation g of x given here?
Yeah, so when we have X and Y, so first when looking at X, we look at the horizontal translation. Oh, we kind of work with that factor. So the horizontal translation being you take the K, and we said it was 1 over K, so that's 1 over KX. And then you have to do plus P, because the minus P, when you move it, you're at, because we're dealing with the coordinate point, like what are you actually doing to the point? So if you're doing minus P, you're moving it to the right P units, so therefore you just plus P on that X value. And then with the Y value, we deal with the outside of the square brackets. So you first deal with the A, which is the vertical stretch. So you just do AY, because you're multiplying it like we did with 1 over K. And then the plus Q is because we're moving it up or down by a
Perfect.
vertical translation.
Perfect. Perfect. So let's have a question from my question set. I've selected a question number 7 for you. So this is a very good question. Can you please read the question and answer?
Yeah, so question 7, what is the domain and range of the function g of x, which equals minus 2 root x plus 1 minus 3?
Yes. How will you do this?
Okay, so um, can we sketch or no?
Yes. First sketch.
Okay,
So when you get square root, you know the parent function is square root of
it's
x,
like that.
which is like this, right?
Yeah,
We have this, and some key values starting with 0, 1, 1, right? So those are your key values.
yeah.
Now, tell me, look into this transformation and then tell me what could be the domain and range of this function.
So if I was trying to draw the g of x graph, I would first move it one place to the left,
Hmm.
then move it 3 units down. But because I've got the minus 2, I know we are having what's it called, a reflection in the x-axis, and then because you're multiplying it by 2, you got a vertical stretch.
Correct. So this will be the reflection in the x-axis, right? And
Okay.
then you say that you will have vertical stretch, so it will be kind of like this, correct? So you
Yeah.
can say this is minus square root of x, and this is minus 2 square root of x. Is that clear?
Oh, yeah,
Right.
yeah.
And
I
then
think
you
it
do
should
the
work in steps.
translation.
I kind of went all over the place. I should
Yes,
work as it's written.
yes. These are the
Oh,
steps, you're
okay.
right. And then the last thing is translation, which is 1 unit to the left and 3 down. So this point goes 1 left and 3 down, correct?
Yeah.
And so it could be this as a final graph. So the point which is here is basically -1 and -3, correct?
Yeah.
So from here you get your domain and range. clearly the domain range is defined by these 2 points, basically, correct? And you can see the direction,
Oh,
which is this minus sign. So we get our domain range straight, that it is to the right of -1. So domain is greater than equal to -1, and the range is less than equal to -3. And you get D as the right option, correct?
yeah,
So whenever you're looking for domain and range for a function, important things are not stretches and compressions. You get my point?
right. Yeah, it's
I mean, it
translations.
could be, it could be. I'm not saying it is not always, it could be.
Mm,
But most important thing is the translation, because you are moving the point from one place to the other, correct?
right.
And the
Yeah.
reflection, because the reflection will take you either to minus infinity or to plus infinity. Those are very
Right.
critical. Well, of course, as you said, Emmy, rightly, we should look into the transformation. So we have the original function to start with, correct? And then step number two, slowly we should incorporate transformations. And the order of transformation, which I prefer, is from left to right. Do you see that?
Oh,
Left
I
to right.
see. Yeah.
So as you can see here, we had that function. Then I first thing I did was step number one was that reflection. Do you see that? And
Hmm.
then second step was
Times by
stretch.
two.
And then I
But
went
yeah,
inside. There is nothing horizontal stretch or compression, but there is a translation, right? So we get left and then we went down, correct? And
down
we get.
three.
So left to right is the order to be followed for any transformation. It does take care of order of formation translation also. Is that clear to you? Correct?
Yeah, yeah.
Perfect. So I think this is done. We'll take another example just to be sure that we have understood these concepts absolutely well. Rational functions are very tricky. We saw it last time, especially to explain the transformation of a rational function is very difficult. But this is a very simple question for you, which is, can you please read the question?
Yeah. So, what is the domain and range of the function g of x equals to 2x minus 4 over x plus 3?
Yes, tell me.
So x cannot equal minus 3 and x cannot equal 2. So you have to look for the, and because it's not inverse, you don't have to do any like switching or anything.
No, no, no.
So you just simply look at those values and then which ones are they? Minus, so
Horizontal
x,
asymptote and vertical asymptotes, correct?
yeah.
So when you have a
So is it
rational function for domain and range, what you have to look for is the horizontal asymptote and the vertical asymptote, correct?
right?
So vertical asymptote really means that the denominator cannot be zero, and the horizontal asymptote, it depends
Cannot be
really
0.
on the order of the degree of the numerator and denominator. If
Right.
the degree is same, in that case, it is the ratio of leading coefficients, correct? So 2
Yeah.
over 1 is the leading coefficient, and that is how you get your answer. That anything where x is not equal to -3 and y is not equal to minus 2, and therefore, in this case, option B is the right option, right? So
Yeah.
sketching a curve quickly helps us to immediately see the solution rather than do or calculate. Do you understand?
Right.
You
Right.
have to see, visualize the solution, correct? Now, let's get into the second part of it, which is not a question here, but which will be the following question on this particular thing, and that is explain the transformation from f of x equals to 1 over x, right? So from 1 over x to g of x, correct? Can you explain me the transformation of g of x starting from 1 over x?
Um, so I know there's a plus 3 on the denominator.
Yeah, that is moving towards the left by 3 units,
3 units.
and
Yeah.
this horizontal is moving up by 2 units, and this 2 could be a stretch factor. Do you get the idea?
Mm.
Okay.
But you said could be.
Yeah, it could
So
be very important.
yeah.
Could be. So let us try to visualize it how it could be, right? So now see,
Right.
uh, we can factor it in many different ways. One of the ways is, I'll just show you. We have x plus 3 in the denominator, right? So what I will do here is that we have 2 there, right? So we have 2 times, let me write this as 2 times x. And what is 2 times 3? 6, correct? 2 times
6.
3
Yeah.
is 6. So if I have plus 6, which I need, I could factor this, right? But I have -4 here. So what I did was I added 6 and subtracted 3. Do you see that technique?
Yeah. Which is 0. But then you
Which
can
is 0.
factor.
Yeah. but
Oh,
it helps me to factor. You get the idea?
yeah,
So
yeah.
from here, I can write 2 times x plus 3. Do you see this x plus 3 now coming up? And
Oh,
the
I see.
number is minus 10. Do you see that minus 10 now? And x plus 3 in the denominator. And therefore, I can now write this as 2 over this x plus 3, x3 cancel 2
And
plus minus 10 over x plus 3. I cancelled it. You see that?
yeah.
Get the idea? So, so you see this 2 is actually corresponding to the horizontal asymptote. We are never there, but we are approaching, and that 2 minus something means on the right side, we are approaching from bottom. Do you understand? So I could actually
Oh,
sketch it.
I see.
Minus means we are approaching from bottom on this side, but if this is negative number, then we are approaching from top. Do you see that? So we actually get the graph also. You get the idea?
Oh, right.
Transformation. And if I
Yeah.
substitute x as 0, right? So we can always find what is f of 0, right? That is the y-intercept, which is minus 4 over 3. So we know that minus 4 over 3 will be somewhere here, right? So the graph
Yeah.
will be kind of like this. Do you see, make the sense?
Mm-hmm. So is that method that you did called partial factoring?
Not exactly.
Oh,
But yes, you we not exactly. Partial factoring, I'll
oh.
explain you separately, right? We'll do that. But this
So
is
the
the
+6 and the -6, that's just a method you need to know in
yeah,
finding
that's a
common
technique.
factor.
That's a technique
Okay.
to break. Uh, I should say the polynomials in a way. Rational functions could be written with some common denominators. You get the,
Yeah.
so
It's actually like you do completing the square. Don't
it
you
is,
add the square
yeah,
and
add
then
or
subtract
subtract
this
like
one?
this kind of a technique, which is this. You may
Yeah.
we may add this technique to partial factoring. We may add this
Oh,
factoring to partial factoring also, but this is very similar to the strategies adopted in partial factoring. I should say that,
all
right?
right.
But
Okay.
I keep this as independent technique or a tool to work with
Okay.
simple equations. Is that okay?
Yeah, yeah.
Perfect. So you got your curve. So with this, we have learned so many things. I have a rational function which I have actually split into a number and a rational function. Right? Now,
Mm.
that number gives me the idea of horizontal asymptote, right? Because we are approaching that, we're never there.
Right. Yeah.
And the independent factor, the term which we have, gives us the vertical asymptote that, again, there is a restriction in the domain that x is not equal to minus 3, correct?
Mm-hmm.
So from this equation, we get the transformation also. We can now explain the transformation that, well, g of x for us is what? G of x is minus 10 over x plus 3, right?
Yeah.
And plus 2. So basically, we are reflecting the graph over the x-axis. So there's the vertical
Oh,
reflection. There is a stretch by a factor of 10.
10. Yeah.
Horizontally, we are moving 3 units left, and vertically, we are moving 2 units
Two
up.
units up. Oh,
You
okay.
understand this? Very
Yeah.
important question. And with this simple example, we can actually learn all these concepts. They all come together. You see that? And
Oh,
these are actually 4 parts of this question, which you can see in Cambridge University test exam, GCSE, like
right.
uh, A plus or whatever, right? You get the idea?
Yeah, yeah.
Let's take another question, right? So here is another one where we have taken. Can you please read this question?
Yeah. So find the range of the function g of x, which equals -2 half x plus 1 whole squared plus 3, where x is in between -4 and 4, both included.
Yes. So domain is given to you basically, right? Therefore, I'm not asking you a domain for this function because domain is given to you, correct? Domain is
Done.
between -4 to +4. So we are
Yeah.
now interested in the range of this function. Tell me, this is a parabola. As you know, the parabola will open downwards, correct?
Yeah, because
So
it's
something below
minus.
that, we need to find the vertex, right, to get the range of the function. The idea is, however,
Yeah.
we are also given a restricted domain, not the whole parabola, right? Within that restricted domain, where is the range? So it will end. It is not going till infinity. Do you see, get an idea, right? So
Yeah.
somewhere from top to bottom, you have to figure out. Now, can you please tell me, how will you find range of this function given to you?
Um, well, I was thinking of when you said to find that point, that maximum point, can
Yes.
you just take it from the graph as -1, 3, or no?
Oh, this is half here, right? So yes, when will this become
Oh,
zero?
sorry.
Yeah.
Yeah.
So you can say half x plus 1 equals to 0, right? You will calculate like this, right? So
Yeah,
half
yeah.
x equals to -1. So x is equals to -2, not -1.
-2.
You
Yeah.
see, that is also a hidden thing where a
Oh,
student can make a mistake. And minus
yeah.
1 is not given here in the option. I should have given some, but it's part of domain. Anyway, so clearly, at x equals to minus
-2,
2, you
3.
will have
Yeah.
your peak, correct?
Yeah.
And of course, the peak is at 3, whatever that value is. And
Right.
important thing is that the -2 is given within the domain. So that means this point is between -4 and +4. Is that clear to you?
Yeah. Yeah.
So you're right. So we got the maximum, which is 3. So it has to be, because this is negative, it has to be below 3, right? But how
Mm.
much down? So for that, we'll check the end values. So find the value of the function at -4 and find the value of the function at +4. That is simple,
Mm.
right? So that you know what are these points for you. Is that okay? So just
Yes.
substitute the value and you say, well, this is -2 times. If I put -4, that it is -2, -2 plus
Plus
1 is
1.
-1, and here
Yeah.
it is 1 plus 3, right? And so in this case, it is +1. And if I substitute 4 in here, then it's -2. 4, 2 plus 1, 3, 3 square is 9, plus 3, right? So it is -18 and so -15, correct? So
Yeah.
it is from -15 to 3, correct? So we get this as our option. Do you get the idea?
Mm-hmm. Yeah.
So the important point is the end points are very necessary. So we just kind of sketch this graph. Let me just do it in a different color now. And so we get this graph kind of like this, right? And that point is 15, correct? And this point is maximum. So it is going from 3 to 15. Is this clear to you?
Yeah. Really clear.
Right. And we have to be very sure that the peak was within this interval, right? Otherwise, the graph could be like this, right? I mean, somewhere from here. Do you see that?
Oh,
It may not
okay.
include the maximum. It may not. Who knows, right? So you have to be very
So if
careful.
that happens, what do you do?
Oh, then the endpoint will tell me, right? Those are the two endpoints.
Oh, okay. Yeah.
Because
Yeah.
yeah, because that vertex is not there. So but if you only do the endpoints, you don't get the maximum. So
Yeah.
be careful. You have to get the maximum and the endpoints to get the proper answer. Is that clear?
Oh, right. Okay. Yeah.
So, and the last question on this topic, we'll just talk about some domain range. In that function, since the domain was given to us, here also the domain is given to us. Anyway,
Yeah.
can you read this question, please?
Yes. So, question 13. Domain of the function f of x is 0 to 10, both included, and the range of the function f of x is -1 to 1, both included.
Hmm.
What is the domain and range of the function g of x, which equals -3 f of x plus 2 plus 1?
Correct. How will you do this?
Um, is it that whole image point thing? So I have
Yes,
to
yes,
I have to make a formula for
yes,
the transformed point.
correct. Do that. Yeah, very good. Make a formula. That
Okay.
is what it is, right? So the x
So
value is, tell
um,
me. Yeah,
x minus 2,
yeah. And y
that's it.
value,
Y
y
value is -3y plus 1.
correct. And as far as
And then,
domain is concerned, we are only looking for x values, right? So let's
right.
talk about domain
So
first.
just sub in,
So domain is
um,
from 0 to 10, correct?
yeah,
So 0 will become what?
-2,
Correct.
1. No, yes, 1.
We
No.
are taking away 2 from it, 10, right? So 8, right? X minus 2. Both are x
Oh,
values.
sorry, that's x
Right.
and y value. Yeah, yeah.
So only look into the x
It's
value,
quite
right?
hard. Yeah,
Easy,
yeah.
easy. So these three questions I have selected for you because there are three variety of questions. Right? I'm not
Oh,
doing any
okay.
duplication. So I don't try to, I just give you just the right thing. That is the
Mm.
key, right? So we got the domain. Do you see that domain now?
Yeah, yeah,
Range, not tell me range. So only y values now, correct? So range
yeah.
is from -1 to 1. So what happens to 1? Minus 1?
So -3.
Minus times minus. Minus 3 plus 3 plus 1, 4, right?
Yeah.
And if you multiply 1 minus, but we'll change it. I agree with you. So minus 3
Wait,
is
is it not?
going to be minus 2, but we'll not write like this. We'll write it like minus 2 to 4, correct?
Is it not? Do we not sub in the -1 into the?
Yeah, it is minus 3 times minus 1 plus 1, correct? So that becomes 3 plus 1. Is it clear? Minus minus becomes plus. Minus 3. You're not looking.
I thought we sub in the -1 where it says x minus 2. So
No,
you
no,
get
no.
-3.
We are talking about range. So you have to now look into the y values.
Oh.
Yeah, now we are looking into the range. What happens to the y values? Is that clear to you? So this
So you
is the
sub
range.
both of those values into -3 y
Yes,
plus 1.
yes, yes, yes. Both are y values.
Oh.
Yeah. So the graph, whatever the graph is. So what they're trying to say is something like this. Let's just try to sketch the graph. The domain is from 0 to 10. That means we have something from, this is not the point on the graph, this region, right? Domain is from 0 to 10, right?
Yeah.
And the range is from -1 to 1. We don't know where the -1 is there. Or we can say, well, this is kind of, let us make it simple, right? Let us say
Yeah.
this is your graph. You understand now? So this is from -1 to 1. Is that clear to you? Where this is domain is from this point is at 10. Do you see?
Oh. Yeah. Yeah.
Correct. So when you talk about the domain part, in that case, you're only looking into this portion. So we'll just see what happens to the x values. We are shifting it 2 units to the left, right? So the whole graph shifts 2 units left. I mean, if you look into that part, correct? It will actually shift by 2 units left. Is that clear to you?
Yeah.
As far as
Yeah.
the domain is concerned. But as far as the y value is concerned, we are actually reflecting it. So that goes on the top and this comes bottom. Do you see that?
Oh,
So we are
I
looking
see.
into
Yeah.
what happens to the y values. And that is the range.
Yeah.
Therefore, this range was applied to the y values. Okay. So of
I
course
got it.
we got
Yeah.
4 and -2, but we have to write in proper order, right? So y
Oh,
value is
okay.
greater than -2, but less than 4. So basically, if you apply this, this graph will go from this is very high 4 value from here, and this will be kind of like this. You understand?
Yeah.
Where if I just use this point, that point now becomes -2, -2, not -2, -2, 8. 4, right? -2, 4, correct?
-2, 4.
Yeah. And the other point becomes uh,
-2, 8.
4 minus 2. This is 4, 8 minus 2. 8 minus 2. Minus.
Yeah.
So kind of tricky. Do you understand? It's not that
Mm.
simple. So you visualize like this. If I give you domain range separately, correct? Of
Mhm.
course, their domain range are separate. And
Yeah.
apply a transformation on it, then domain part, keep it the x values. What
Okay.
happens
Yeah.
horizontally? Range part, y values. What happens vertically? You get the idea?
Yeah. Makes sense.
That is what we should be doing. And these are the type of questions which you should expect in transformation, which might just create some confusion as it did, right?
Mm. Yeah, when I was at like when I was doing year 12 maths,
Mhm.
when we had in exam questions where we had a point and then you had to move it according to the changed graph. But this method's so much easier. I used to take the point and individually do each of those transformations, but I always like forgot which transformation I did. But it
Mhm.
took so long. Whereas if I just create a formula and sub them in, I'm literally
Yeah,
done. You
yeah,
know,
yeah.
so
That's good.
quick.
Perfect. So always what you have to do is correct. You just make like this, right? This is your xy, and this is your xt transform point, right?
Yeah.
Very simple, right? And then write down your transformation as we did, and you can take some points and see the result, and then couple of
Yeah, super helpful. I like that method.
yeah. So you can easily do. Perfect. So I think that's a good review. Now, is this part clear to you?
Yeah, super clear.
Yeah. So we'll
Thanks,
actually
sir.
continue and we'll take up absolute functions. Then the idea is we'll incorporate transformations and inverse of functions using absolute functions also. So absolute
All
functions,
right.
modulus functions, what you say, these are slightly tricky functions. They are also piecewise functions. So let's look into these functions, right?
Okay.
So
Yeah.
here's my lesson on absolute functions. So now we'll discuss what modulus or absolute function is. It is basically a piecewise function. So we'll break it up in two pieces. And normally, when we have to solve equations or inequalities, we'll use with those two pieces separately. Okay,
Okay.
we'll see how to find equation from the graph or how to graph a equation. And there's a relation with absolute functions and the number line, right? So we'll see how number line, which is shown
Oh,
here, is related with the absolute functions. Normally, when you write solution of inequalities, you put those solutions on a number line, right? For example,
right.
here is one of the solutions. Now, what is my solution is x values are less than 1 and x values are greater than 5, correct? So on this some questions, I have this answer which is greater than 5 and less than 1, right? How do I represent this as an absolute function? Can I represent this as an absolute function? That is a big question, right? We'll see
Yeah.
how can we do it, right? So in that
Okay.
case, this is very interesting. So likewise,
Yeah.
we have some practice questions and test review. Just as we did a quick review on transformations, now we
Yeah.
will do quick review on absolute functions. Perfect.
Yeah.
So
Sounds good.
I always begin with one very basic question, which you might have come across. What is square root of x squared?
Plus or minus x.
Very good, beautiful.
I've
Plus
learned
minus x,
over
but
the
it
years.
is still not the right answer, because when is it plus, when is it minus? You are not telling me that. You get the idea.
Yeah.
So the exact value is this is equal to absolute value of x. Do you see that? Because square
Oh,
root is always positive. You get the idea? Square
yeah.
root is always positive. So it is absolute value of x. And you know how your answer is correct is because when the x value is already greater than or equal to 0, we keep it as such. We keep
Yeah.
it plus x. However, if the x value is negative, we make it negative x. Do you see that? That's what you meant by saying plus or minus x, right?
Mm.
Critical parameter was when is it plus and when is it minus. So
Yeah. We
that
don't
is
know that.
when, right? So what I'm trying to say here is a very simple thing, is that if I have a line which is y equals to x, let me just sketch it here. Uh, if I have a line which is y equals to x, right? In that case, I maintain this side for an absolute function as such, right? Because this is a positive side. My
Yeah.
absolute function is always positive, is never negative. So what I do here is I reflect this part and draw it like this. Do you see that this becomes the
Oh, that goes
absolute
on.
value of x? Do you agree with me now? Which
Yeah.
represents
Yeah.
how we reflected the negative half into the positive half reflected over the x-axis. Do you see that?
Oh.
And that is why it is a piecewise function. So we got our absolute value of x. Is this clear to you?
Yeah. Yeah. So if you say again, if you ever ask me what is the square root of x squared, the answer is the absolute value of x.
Yes, this is what absolute
Oh,
value of x is. You
I
get the idea?
see.
This is
Yeah.
what absolute value is. Square root of x squared. To give you an idea, let us say we have minus 7 square root, right?
Yeah.
That means what? Square root of 49, correct?
Yeah.
That is 7. It is not minus 7. It is not x. X is minus 7, right?
Yeah.
X is minus.
Oh,
But you could write this as minus 7 absolute value, which is 7.
therefore 7. Yeah.
Absolute value of
Got
x.
it.
X could be, in this case, x is equal to minus 7. You get an idea? So
Yeah.
that
Yeah.
is the right answer.
Oh, I see.
Perfect.
Yeah.
So this
Yeah.
is a beautiful introduction to absolute value of x. We should understand algebraically and geometrically what does it mean, right?
Yeah.
Now, realistically, What is absolute value? In real life, we are not so finicky about numbers, right? When I say
Mm.
I need 1 meter length of a cloth for some purpose, right? Let's say
Yeah.
I want to buy tablecloth, for example. Let's say I need 3 meters of a cloth so that I could make a tablecloth. That's the whole idea.
Yeah.
Now, how precise do I need this 3 meters? Is it 3 meters, 1 centimeter, 3 meter, 1 millimeter? Like what accuracy?
Yeah.
That is what absolute value is. Is plus minus 1 centimeter will work for me. You get the idea.
Oh, okay. Yeah.
I will work with plus minus 1 centimeter. So 3.1 or 2.9
No.
will work for me.
Yeah.
So always practically, we are looking for a tolerance. Tolerance is like plus minus something.
Right.
Either it is on the lower side or on the upper side, doesn't really matter. Correct?
Yeah. Like bounds.
It works. That is
Yeah.
the real application of absolute value of a function, right? So in real life
Oh,
situations, when you have this, for example, I'm a lover of wildlife, and I see, well, turtles when they lay eggs, if you
yeah.
like incubate them at a particular temperature, uh, let's say the range is from 25 to 30 degrees, but if you
Yeah.
incubate at the higher range of 29 to 30, then females will be born. But if you incubate on
Oh,
the lower end, then the males will be born.
yeah.
So what are we looking for? We are looking
That
for a
tolerant.
tolerance of zero point 0.5 degrees, correct?
Right. Yeah.
So 29.5 plus or minus zero point 0.5 will give me females. You get the
Right. Yeah. Yeah.
So the temperature controller in that particular room will be set to 29.5 with a tolerance of zero point 0.5, and they will ensure
Oh,
that only females will be born. You get the idea?
yeah. Yeah.
Huge. Because we cannot make an instrument which is like absolutely
Yeah. Accurate.
precise, that
Yeah.
absolutely has an absolute error.
Right. That's true. That's why we need this tolerance.
Uh,
Yeah.
Therefore,
Got
in,
it.
in most of the applications, absolute function will be used some way or the other.
Mm.
So whenever you want to find whether what is the grade point of the student, right? So we want to do A or A plus. So there is a tolerance, correct? So we'll look into all
Oh,
those things, grading system and everything, correct?
yeah.
So many places will use the absolute function. Is that part clear to you?
Yeah. Yeah. Clear.
Okay, great. So with that, let's go into the characteristics of absolute function. Now, whenever we talk about any function for that matter, I would like to have a framework to work with. So here we have a framework, as you can see. What I do is list all the properties so that we do not forget about any property, correct? All which we are
Right.
interested in, we put them one side, and we can follow the same pattern for different functions, right? It is sinusoidal function, linear function, cubic function, whatever, right? Exponential
Yeah.
function, whatever. But if we have a framework, we can put all the characteristics there, correct? Now we're talking about absolute value function. First thing first, let us define the function. What are we trying to say, right? We're trying to
Yeah.
say it is equal to minus x if x value is negative, that is less than zero. But it is x only if it is positive, greater than equal to zero, correct? That is
Yeah.
defined. And here is a graph of the function. Clearly, this graph in green shows you the absolute function. So from here, we can say, well, what is the domain? Domain is all real numbers. Ranges, it is non-negative. Real numbers greater than equal to zero. Important, symmetry. As you can see, it is symmetric about the y-axis.
Y-axis.
So it
Yeah.
is even symmetry. Even symmetry means what? Even symmetry means that for every minus x value, you have the same y value. So it is like symmetric like this, right? So if we have a point here, it has a mirror image on the other side. Do you see that? So if we have a point
Oh,
on the left
yeah.
side here, so what we say is absolute value of minus 5 is equal to absolute value of 5, and both are equal to 5. Do you see that symmetry?
Yeah.
Or you could say mathematically, as I have written, f of minus x is equals to f of x. That is what even symmetry is. Is this clear to you?
Yeah. Yeah.
Like a parabola, y equals to x squared. It has even symmetry. Trigonometric
Right.
function cosine x, right? Cos x has even symmetry. So there are many functions which have even symmetry, including absolute. Now, what
Yeah.
are the x and y intercepts for this function? the vertex is at origin, and therefore both x and y intercepts are at the origin, right?
Right.
Decreasing and increasing interval is also very important while we are describing a function. So you have to see a graph from left to right, right? To say left to right, when you move, what happens to the graph? So
Yeah.
it decreases here, correct? So it is decreasing when x is less than 0, but it is increasing when you're on the right side of the origin. Is that clear to you?
Yeah.
End behavior really means what happens when x approaches a large value. It could be positive infinity or it could be negative infinity. In both the cases, what we see is that the y value approaches positive infinity, correct? It is going high, correct?
Yeah.
Expected. So that is the end behavior of this particular function. Rate of change is another very important parameter. Rate of change says if any point I take in this particular case on the left side, we have a slope which is -1, right? And on the
Right.
right side, it is positive
Plus
1.
one.
What happens at the vertex? Can you tell me? Is the rate of change defined at 0, the origin?
No,
It is
it
not
does not
defined.
exist
Okay,
because
does not
oh,
exist is the wrong term. Okay,
oh, it's
very good.
undefined.
Does not exist. So, very good. Because you're a good learner, so you will step on the things which will help you learn things which you have, forgotten.
Yeah.
Undefined means here, I could say the tangent is 0, thinking x-axis is my line, tangent is
Yeah.
-1, +1, or any other value. It's like a V-shaped structure sitting on your table, right? Any
Yeah.
line on this plane of table will be tangential to the object. You get the idea, correct?
So you don't know what
You
that
don't know,
gradient
so it
would
is
be.
undefined. So function undefined means relation, not a function. Undefined. You get the
Oh,
idea?
yeah,
Does
yeah,
does not exist will be in the case of, let us say, if I have 1 over x function. Do you see that? Now, if I ask you, what is the tangent at x origin? It does not exist.
oh,
There is no point there. Do you understand?
yeah.
Does not exist
Oh,
means
I
this.
get it. Yeah. So if there's a point and then you can have many tangents to it, then it's undefined because you can
Correct.
actually draw a tangent to that point. But in this case, there is no point, so you can't say,
Does
so it
not
does not
exist.
even exist. Oh,
Yeah.
got it.
Multiple choice questions will have both the terms undefined and does not exist. Believe me or
Oh.
not. And the other two
So they don't
options,
mean the same thing.
five options are +1, -1, 0, does not exist, undefined. Tell me.
Wow. Every option under the moon. Okay.
All the above, none of the above.
Yeah.
Oh my God. So the precisely correct is
Yeah.
undefined. Okay. Very, very important.
That's a hard test,
Very, very.
whatever it is. The multiple
Okay.
choice.
So, so yeah, I think you got this idea, right?
Mm.
Now let us see how do we solve equations which are based on absolute function. Okay. So I have one equation here. Absolute value of x is equal to 10. Can you tell me what is the value of x? We will quickly go over it. What could be?
Minus 10 or 10.
Perfect. Now this one, absolute value of x is -5.
Um, 5 or minus 5.
None of that.
No, 5. Sorry.
No solution. It cannot be negative.
Oh, yeah, because it has to be positive. Sorry. Okay, I'm screwed on. That was a cheeky
The
one.
absolute function is very tricky. Okay. So
Right.
now
Okay.
let's look into this, right? Fractions everybody is scared of. Tell me, how will you solve f, which is 2 over 3 absolute value of x plus 5 equals to 14? Simple things first.
Um,
14 times 3 over 2, right? Which is
yeah,
7 times 3, 21. So we have got absolute value of x plus 5 equals to 21. How will you solve this?
21 take 5.
Okay. Okay, 21 take 5 is x.
So
Okay.
16.
Okay.
X could be 16.
Or what? There are two solutions. Absolute value is
Yeah.
like a V shape, and so we are expecting two solutions.
Um,
So, okay, you gave me partial solution. So, what we will do,
um,
let's learn the method.
minus.
Yes, you are going there. So, what we will do here is we'll split into two. As I said, absolute value is a piecewise function. It has two
Yeah.
beautifully aligned pieces, right? So, we'll say,
Hmm.
well, x plus 5 could be equal to minus 21, or x plus 5 could be equal to 21, because
Yeah.
both will give me plus 21.
Oh, yes. That's what I was trying to do. Yeah, yeah.
So
Okay.
we get x equals to what you said earlier, 21 minus 5, which is 16, or x is equal
Minus
to
26.
minus 26, right? Do you see that?
Hmm.
That is how you're going to solve absolute value functions. Is that clear to you? So
Yeah, yeah.
piecewise function, split it into two halves and then do it, right? Okay. Now we'll have another kind of a question, very popular. Can you please read this example?
Yeah. So write the following solutions as absolute function.
Yeah, the
So
solution. Now I have given you the solution. My solution is equals to plus minus 4. What is the
mm,
absolute function for this?
um 4. I don't know how to say it. Do
Absolute
you
value of 4, x is 4.
absolute value of x is 4. Okay.
You use modulus, right? Modulus of x is 4. Is that same thing?
Okay.
Yeah, we in North America use more most of the time absolute value, but a
Okay.
modulus of 4 is a modulus of x is 4. Yeah, it's difficult for me to say, right?
Oh, okay.
The,
That's all
the
right.
thing is why it is difficult for me. There's another function which is called mod function. Mod function. Is it clear to you?
Oh, is it not the
Mod
same thing?
function. Mod function tells me what is the remainder after we divide.
Oh,
Yes, it's a different function. And then we have modulus.
so
Modulus
they're
is an
two different.
operation which is same as absolute function. Is that?
Yeah. I think I'll just stick to absolute because then I'll get confused.
Yeah, but your books will use modulus, so be careful.
Oh, okay.
But never use mod when you're talking about absolute function.
Oh, right. That's a different thing. Yeah.
Yeah, right. So, say if I say 3 mod 10, it means remainder is 1. I'm saying 1. You understand? That's a different function.
Yeah.
So, be careful about that. Okay, now getting back to this, we are saying C is very interesting. We are saying that solution of an equation is x equals to minus 3. What is that
Mm-hmm.
mod equation, modulus equation, or absolute value function?
Nothing.
Tell me.
Nothing.
Nothing
Because
wrong. Wrong answer.
what?
What? This is what mathematics, what
I
absolute value is. So we are saying that the solution is minus 3. Oh my God. But absolute function is never negative. What to do?
yeah.
Oh my God. Now I'll tell you a key.
You're literally thinking exactly how I'm thinking, which is really funny. Okay.
So the
Yeah.
key is one value. One value is only possible if the vertex is at this point. Does that give you an idea? Now I get one value. You get the idea? So
Oh.
what can I say is absolute value of minus 3 means x plus 3 is equal to 0. What is the solution? Tell me.
So it's either
Plus 0, minus 0, same thing.
yeah, that doesn't work.
So it works. X plus 3 equals to 0. X is equals to minus 3. It works.
Oh, it's just that you can't have plus or minus because we're at a corner, so it's only one value.
One value. So we got the absolute value function, and the answer is
Oh.
absolute value of x plus 3 equals to 0. Do you get it?
Mm. Yeah, yeah. That's
Perfect.
tricky.
Very tricky, right? Now,
Yeah.
tell me, we'll talk about that. We'll talk about f. All real numbers. Absolute value, you have to give me a function whose answer is all real numbers. What will you say?
Uh, just absolute value of x equals just that.
When we have more than two
Greater
answers,
than
it is
0.
an inequality. When we have more than,
Oh,
the equation will give me one or two or no solution. Is that clear to you?
yeah.
But inequality will say absolute value is greater than equal to 0, or absolute value is greater than minus 1. All real numbers are greater than minus 1.
Oh,
That is
yeah.
how we are going to give that answer. And next one, here, solution does not exist. Tell me.
Uh, so is that where there's no absolute value?
No, absolute value equals to negative 1, for example. Yes. Then it is never negative 1, so it does not exist.
Yeah, so I meant like,
Yeah,
yeah.
yeah. Now the
Okay.
difficult ones, very difficult ones, is F. Absolute value is -3 or or 7. This is equal to sign. Now we don't have plus and -3. We don't have plus and -7. We have two different values. X is equal to -3 and x is equal to 7. And I have to write this as an absolute function. How do I write this? Oh my God. How do I
Is it
write?
like you did in part C, some sort
Yes,
of like
yes, yes,
transformation
yes.
thing?
It is as in part C. Do you see now these two values are not
Yeah,
symmetrically placed? So how will you do it? Tell me now. Yes, you got an idea about it. So
I got the idea, but
yeah.
about solving it is a different case. Um, so you draw a graph where we want a value at -3 and 7, but at 7 you can have two values. But at -3 you can only have the cusp. No, the corner.
No, now I'll teach you the method, right? So
Oh,
the thing is, this is insight to absolute function. Beauty of absolute
yeah.
function, it is symmetric about its vertex.
Origin. Yeah.
So basically, we have to put it in a way that these 2 points are there at the end, and we have something in between. So what is the mid value of this average value center?
Um,
-3
so
plus
-3
7.
add 7 divided by 2.
So 4 divided by 2 is 2, right? So
2.
this point is 2. So we got the center point, correct?
Yeah.
Now, absolute value is like I say, right? I want to live near the airport since I travel a lot, right? So I
Yeah.
want to be like within 5 kilometers of the airport. So I could
Yeah.
be east, west, north, south, anywhere. So I've got a point which is the airport as my center, and I could be around it, right? So we found the point 2, which is in between, exactly between -3 and 7. And how far am I? Just calculate that. Simple as that. So we are 5 units away. Is that clear to you?
Yeah.
So I can write this as an absolute function. Absolute value will be x minus 2 since I moved to position 2 and I want to be 5 units away. So I get the answer as -3 and 7. Do you get the idea?
But why can't, so if you dealt with the distance between 2 and -3, it would be the same because
Yes, yes,
it's
yes. 2 and
minus, it's still 5 units. Okay.
still 5 units. -3 if you want to go 2 to 0 is 2 units and then 0 to 3 is 3
Yeah.
units. 2 plus 3 is 5.
Okay.
Perfect. So basically you could say, well, we have two solutions here. Let's go reverse, right? X minus 2 equals to -5. That means x minus 2 equals to -5 plus 2, which is -3, correct? You get it?
Oh,
Or I could do +5. So x minus 2 equals to +5.
+5,
X equals to 5 plus 2,
7.
which is 7. You get the idea. So the
Oh,
steps involved are come to the center and check how far are you from the center. You get the idea?
yeah.
And you get your
Yeah.
equation.
So would you just do the same then for those inequalities, D and H?
Yes,
Same
yes.
principle.
Yeah, tell
Okay.
me,
Okay.
what is the answer now? So, yeah, tell me answer for H now. Can you please read? X is less than 2 or X is greater than 10. How will you tell me absolute function inequality which has this answer? Tell me. First,
So we know 6 is the midpoint, is where the corner is.
yeah.
And then how many units away from 10? So it's 4.
Yes.
So it's X minus 6 equals
Greater.
4. Greater than.
You're going away now. You're not with at that point. So you're greater than 4. Is that clear to you? It is an inequality away
Oh.
from this. So that is an equation. This is
Wait, how
inequality.
come? Oh, because that literally has an equal sign in it. This has a greater than sign.
Greater.
Oh, okay.
Away. So when it is greater than, you're going away. I don't want to live within 4 kilometers of a fish market. Very simple.
Yeah, you want
away from that.
Yeah,
This
yeah.
is what it is, right? You get an
Oh.
Does
Mhm.
it make sense to you?
Yes, yeah.
That is the beauty of absolute function. And so it's like huge. And these type of questions may look very simple. They are
It's not.
not that simple.
No.
They're not that simple. So let me just go into, I'm looking here at my screen, extended. We'll end here at extended. What the hell it is there? Okay, this is what we did just now. This is what we did, right? Can you please read
Yeah.
this question?
All right. So example 9, linear inequality to absolute function.
Mm-hmm.
So express the inequality where x is between -6 and 10 in the form of x minus a, the absolute value,
Yeah.
being less than or equal to b.
How will you do it? Yes, tell me.
So so first you need to find the
Midpoint
midpoint
minus
between
6 plus
-6 and
10.
10
Yeah, divide by 2,
divided by
right?
2,
4 by
so
2, 2, right?
2.
Then how
Then
far you are,
you
right? 10 minus 2, 8, correct? How far?
8.
Correct. So what is the equation?
So
Make it equal
absolute
to 10.
value of x minus 2 being less than or equal to, because that's the inequality of the
Beautiful,
question,
beautiful.
and 8.
Easy. So what is the
Oh.
value of A and what is the value of B?
So you need to solve. So it can,
No,
so either
no, no.
x minus 2.
You have to just read.
Oh.
Yeah, they are corresponding values, correct? So A is 2, B is 8. Got the answer.
Oh.
Ah,
Sorry.
you see
Yeah, yeah,
that?
yeah. I
This
thought
is
we had to do that whole thing where you try and find the value by doing the piecewise thing.
you see
Okay,
how
okay.
easily we could do it.
Yeah.
Correct. Well, there are many ways to do it. I have seen some methods which are being followed in GCSE, for example, right? So this is a very common question, like there, right? How we are doing. Let me just share with you different ways of doing it. Okay, that's also a very beautiful way. When we say x minus a is less than equal to b, it means it is greater than minus b, but it is less than b. So it is within
Yeah.
that boundary. Is that clear to you?
Yeah.
Now, we got this. Now, how do we simplify this? We want only x in between. So we added and subtracted. First, we did this. We added a everywhere. We added a all the places. We are doing the same thing, correct?
Yeah,
So we
yeah.
get a minus b on the left side and a plus b on the right side of x, correct?
Oh, okay.
And now
Yeah.
we can solve the inequality. We know a minus b is minus 6 for us,
Equals to -6.
and
Oh, I
a
like
plus b
that.
is 10 for us, and then we solved it. Is that clear to you? So
Yeah,
we do all this and we get our answer. You get the idea. This is the
yeah.
standard way of doing it, right? This is standard.
I like your method better. It's faster, but that's also nice to know. Yeah.
This is important to know because they will say, what is wrong in this step?
Oh, okay.
Communication gap,
Yeah.
right? They'll give you the whole thing, make a mistake somewhere, right? Then you should know the method, correct?
Right, right. Yeah.
So my
But
method is
otherwise, if they don't give that question, I think it's better
okay.
to use your method.
So
Yeah.
my
You
method
literally
is
did it in
very clear.
seconds.
My method is very clear. We are looking for something in between, right? This is A,
Yeah.
this is B, correct? They could be included, they may not be included, doesn't matter. What I do here, step number 1, find the midpoint, which is A plus B divided by 2. Is it okay?
Yeah.
Second is, how far are you, correct? Done.
I love that.
B
No,
minus
and the
that.
fact that that works, is it because it's like an even symmetry and how everything you were saying about that? Is
That is
that why it
absolutely.
works?
Yeah. We're talking about what? The topic of the day is absolute function.
Yeah.
Use topic of the day, which is absolute function,
Right.
not the subtopic inequality.
Okay. Yeah.
This
I
is the
like that.
method of solving inequalities, right? You
Yeah. Yeah.
understand? But what we use the beauty of absolute functions to solve it in 2 steps, midpoint and distance from
From the
midpoint.
midpoint.
Distance is always positive, remember that.
Yeah.
So,
Yeah.
and we get our inequality which matches the sign always. So put the same
Oh.
sign, whichever is in the question, right? Do you understand?
Yeah.
Of
Just
course,
a quick question. You
yes.
know, when we did that other question where we had, so instead of
Okay.
that being the inequality,
Yeah.
yeah, you had them or, and one was away and one was the
Away,
greater
both
than
away,
and
both
less
away.
than.
Yeah, it
So
could
you
be
do both
away.
ways.
Yeah, you have to break that. Away cannot be combined. So one
Yeah,
is
yeah.
less, one is greater than, right? We'll have
Okay.
an example. I think there are many examples here. I think we will do the next one maybe. That is away. Okay, there you go. So can you please read this question? This is what you're talking about, right?
Oh, yeah, yeah. So express the inequality x being less than -7 or like union x being greater than 5 in the form of x minus a absolute value being greater than b. So between minus 7 and 5, you need to find the midpoint by adding them. Dividing by 2 is
Yeah,
minus 1.
correct. And then how far are you?
6 units. No, yeah.
Yeah, 6 units, correct?
6 units.
So what do you write? Your
X
function is
plus 1
x plus 1. And
being greater than 6.
away is this sign, right? Is away means greater than 6.
Greater than 6.
Done.
But you don't do less than.
No, greater than includes both the things. You're writing this as two different inequalities. You see that? When you write
Yeah.
without absolute function, they are written as two different inequalities.
Yeah.
Less than 7 minus and greater than 5. But when you write absolute function, it is 1 like this.
Because it takes into account the everything before it. Oh,
very
got it.
powerful function. Very powerful.
Yeah.
Do you see the idea and the beauty of solution? Correct.
Oh.
Standard method. This is your standard method. Okay.
Yeah.
How long it is?
So long.
And you'll do.
I think they're purposely trying to make it really long.
And now
And they can.
When you have
They can
this,
easily show us.
we done this. We know what is the value of A. A is minus 1 and B is 6. Do you get the idea?
Yeah.
A is minus 1, B is 6. Done. I got my answer.
Oh.
That is how you're going to solve absolute value functions from your textbook, not your book method. Is that clear?
Okay. Yes.
Follow your book
And then
method.
I'll be flying through it.
And you know you have some marking scheme and all, correct?
Yeah.
Your marking scheme will be standard method. Don't follow that.
Oh, okay.
Do my method.
As long as I get the answer, I'm sure I'll get all the marks. So
I think that's a good place to wind up today. So we learned about transformation. This is the transformation. We moved the function, you see, but we incorporated absolute value function on top of it.
Right.
The simplicity and the power of absolute value function in solving equations as well as inequalities.
It's quite impressive.
Very good.
How it ties in everything. Yeah.
Perfect. So I think that's a good place to wind up today. And now you could go through your textbook and your mock tests and whatever you have. You have a lot of material, right? You've been searching internet all over the place.
Right.
So
there's a lot out there.
Yes.
Yeah.
So wherever you have any question, if you have any difficulty, share with me, and then we'll move forward. And
all right.
That
was so helpful, sir. Thank you so much. I loved every minute of it. The methods, the calculations, and then the practical elements to it. So all in all was really great lesson. So thank you.
I think next class I'll take on combination of functions, right? So when we say combination, we have two things where one is the combination, the other is composition of functions. So many people do not really distinguish between the two, but we'll talk about two things there. One is combination of functions, right? And the function of function is the other half, which we
right? Like f of x or something.
Composition, combination. You understand the two terms? Now? When we say add f and g, that is one part. F of g is the other part. That is what we
okay.
F and g is one part, right? But when within a function into the other function, that's the other
composite. Yeah, got it.
So that is what we'll do next time, okay? But I hope something out of this also. If there are any
so much, sir. Not something, a lot. That was so helpful. So I'm going to do all the questions from my book, and then can't wait for our next lesson. So yeah.
Okay, great. Thank you, and all the best.
Thank you so much, sir. Have a good rest of your day.
You too. Thank you.
Bye.